According to the National Electrical Code, any receptacle within 6 feet of the edge of a bathtub or shower must have ground fault circuit interrupter, or GFCI protection. This includes recessed downlights because they are considered a fixed lighting fixture installed in a wet location. If the recessed downlights are wired downstream of the GFCI receptacle, the power to the lights flows through the GFCI device. This ensures that the lights will be de-energized if a ground fault is detected, which helps prevent electrical shock. The code reference according to NEC 406.4 Dun states that receptacles installed within 6 feet of the outside edge of a bathtub or shower shall have GFCI protection. In addition, NEC 410.10d specifies that fixtures installed in damp or wet locations shall be listed for such use. Therefore, it is essential that the recessed downlights installed above a shower or bathtub are rated for wet locations to prevent electrical hazards. Wiring the lights downstream from a GFCI receptacle provides an additional layer of safety by ensuring that any ground fault in a lighting circuit will trip the GFCI and cut off power to the lights. Let's delve deeper into the specifics of GFCI protection and its application to recessed downlights in wet environments. Firstly, it is paramount to understand the function of a GFCI device. A GFCI constantly monitors the current flowing to and from an electrical circuit. Under normal circumstances, the current flowing through the hot wire should equal the current returning through the neutral wire. However, if a ground fault occurs, such as when electricity flows through an unintended path like a person's body to ground, the current balance is disrupted. The GFCI detects this imbalance and quickly trips the circuit, cutting off the power supply within milliseconds. This rapid response is crucial in preventing severe electrical shock or electrocution. Secondly, the NEC mandates GFCI protection for receptacles in specific locations, including bathrooms, kitchens, and outdoor areas where water is present. The rationale behind this requirement is to minimize the risk of electrical shock in environments where people are more likely to come into contact with water and electricity simultaneously. Showers and bathtubs are prime examples of such environments, making GFCI protection essential for any electrical devices or fixtures installed nearby. Thirdly, the term downstream in this context refers to the electrical wiring configuration. When the recessed downlights are wired downstream of the GFCI receptacle, it means that the electrical current flows from the power source to the GFCI receptacle first, and then from the GFCI receptacle to the lights. In this arrangement, the GFCI receptacle serves as a protective barrier for the lights, and any ground fault in the lighting circuit will be detected by the GFCI, causing it to trip and to energize the lights. Conversely, if the lights were wired upstream of the GFCI receptacle, the GFCI would not provide any protection to the lights, and a ground fault in the lighting circuit could potentially result in an electrical shock hazard. Furthermore, it is important to consider the specific requirements for recessed downlights installed in wet locations. NEC 410.10d requires that fixtures installed in damp or wet locations be listed for such use. This means that the lights must be designed and tested to withstand the moisture and humidity present in these environments. Wet location-rated fixtures are typically constructed with waterproof housings and gaskets to prevent water from entering the fixture and causing electrical shorts or corrosion. Additionally, the wiring connections within the fixture must be properly sealed to prevent moisture from compromising the integrity of the electrical connections. In addition to GFCI protection and wet location-rated fixtures, proper grounding is another critical aspect of electrical safety in wet environments. Grounding provides a low-resistance path for fault current to flow back to the power source, allowing the circuit breaker to trip and de-energize the circuit in the event of a ground fault. All electrical devices and fixtures installed in bathrooms and other wet locations should be properly grounded to minimize the risk of electrical shock. The grounding conductor, typically a bare or green insulated wire, should be connected to the grounding terminal on the receptacle or fixture and to the grounding bus bar in the electrical panel. Proper grounding ensures that fault current will flow safely back to the power source, tripping the circuit breaker and preventing electrical shock. Moreover, regular inspection and testing of GFCI receptacles are essential to ensure their continued functionality. GFCIs can degrade over time due to exposure to moisture, dust, and other environmental factors. It is recommended to test GFCI receptacles monthly by pressing the test button on the receptacle. If the GFCI trips and energizes the circuit, it is functioning properly. If the GFCI does not trip, it may be defective and should be replaced immediately. Replacing a defective GFCI receptacle is a simple task that can be performed by a qualified electrician or a knowledgeable homeowner. In addition to testing the GFCI receptacles, it is also important to inspect the wiring and connections of the recessed downlights periodically. Look for any signs of damage, such as frayed wires, loose connections, or corrosion. If any damage is found, it should be repaired immediately by a qualified electrician. Regular inspection and maintenance of the electrical system can help to prevent electrical hazards and ensure the safety of occupants. The NEC is a comprehensive set of standards that governs the safe installation and maintenance of electrical systems. It is updated every 3 years to incorporate new technologies, best practices, and lessons learned from past electrical incidents. Electricians, inspectors, and other professionals in the electrical industry must stay up to date with the latest edition of the NEC to ensure that their work complies with the current safety standards. Failure to comply with the NEC can result in serious electrical hazards, including electrical shock, fire, and property damage. Therefore, it is essential to consult with a qualified electrician or electrical inspector if you have any questions or concerns about electrical safety. In summary, GFCI protection is essential for recessed downlights installed near showers or bathtubs. Wiring the light downstream of a GFCI receptacle provides an additional layer of safety by ensuring that any ground fault in the lighting circuit will trip the GFCI and cut off power to the lights. Additionally, the lights must be rated for wet locations and properly grounded to minimize the risk of electrical shock. Regular inspection and testing of GFCI receptacles are also important to ensure their continued functionality. By following these guidelines, you can create a safe and comfortable bathroom environment for yourself and your family. Let's further elaborate on some of the specific considerations for selecting and installing recessed downlights in wet environments. Firstly, the type of recessed downlight fixture should be carefully chosen based on the location and application. There are several types of recessed downlights available, including incandescent, halogen, LED, and compact fluorescent. LED recessed downlights are becoming increasingly popular due to their energy efficiency, long lifespan, and cool operating temperature. They also come in a variety of color temperatures and beam angles to suit different lighting needs. For wet locations, it is important to choose recessed downlights that are specifically designed and listed for wet locations. These fixtures typically have a sealed housing and gasket to prevent water from entering the fixture and causing electrical shorts or corrosion. Secondly, the size and number of recessed downlights should be determined based on the size of the shower or bathtub area and the desired level of illumination. It is important to provide adequate lighting for safety and visibility, but too much light can create glare and discomfort. A general guideline is to provide at least 50 to 75-foot candles of illumination in the shower or bathtub area. The number of recessed downlights needed to achieve this level of illumination will depend on the wattage of the lights and the size of the area. Thirdly, the placement of the recessed downlight should be carefully considered to avoid shadows and glare. It is generally recommended to install the lights evenly spaced around the shower or bathtub area. Avoid placing the lights directly above the shower head, as this can create glare and discomfort. Also, avoid placing the lights too close to the walls, as this can create shadows. A good rule of thumb is to maintain a distance of at least 12 inches between the lights and the walls. Furthermore, the wiring and connections of the recessed downlight should be performed by a qualified electrician in accordance with the NEC. The wiring must be properly sized for the load and protected from physical damage. The connections must be made using approved connectors and properly insulated to prevent electrical shorts. The grounding conductor must be properly connected to the grounding terminal in the fixture and to the grounding bus bar in the electrical panel. It is important to follow all applicable codes and regulations to ensure the safety and integrity of the electrical installation. In addition to the above considerations, it is also important to consider the aesthetic aspects of the recessed down lights. The style and finish of the fixtures should complement the overall design of the bathroom. There are many different styles and finishes available, ranging from traditional to contemporary. It is important to choose fixtures that are both functional and aesthetically pleasing. Moreover, the dimming capability of the recessed down lights can be a desirable feature for creating different lighting moods. Dimmers allow you to adjust the intensity of the lights to create a relaxing and comfortable atmosphere. However, it is important to choose dimmers that are compatible with the type of lights being used. Not all dimmers are compatible with LED lights, for example. It is also important to follow the manufacturer's instructions for installing and using dimmers. Let's also explore some common misconceptions about GFCI protection and electrical safety in bathrooms. One common misconception is that GFCI protection is only needed for receptacles that are directly exposed to water. In reality, the NEC requires GFCI protection for all receptacles within 6 feet of the outside edge of a bathtub or shower, regardless of whether they are directly exposed to water. This is because water can easily splash or spread to nearby receptacles, creating a potential electrical hazard. Another misconception is that GFCI receptacles are only needed in bathrooms that have bathtubs or showers. In fact, the NEC requires GFCI protection for all receptacles in bathrooms, regardless of whether they have bathtubs or showers. This is because bathrooms are inherently wet environments and the risk of electrical shock is present regardless of whether there is a bathtub or shower. A further misconception is that GFCI receptacles are only needed in new construction. While it is true that the NEC requires GFCI protection in new construction, it is also recommended to install GFCI receptacles in existing bathrooms to improve electrical safety. GFCI receptacles are relatively inexpensive and easy to install, and they can provide a significant level of protection against electrical shock. Finally, it is important to remember that GFCI protection is not a substitute for safe electrical practices. Even with GFCI protection, it is still important to avoid using electrical appliances near water and to keep electrical cords and devices away from wet surfaces. It is also important to have your electrical system inspected periodically by a qualified electrician to ensure that it is in good working order. By following these guidelines, you can create a safe and comfortable bathroom environment for yourself and your family. Ensuring electrical safety in bathrooms and wet environments is paramount, and understanding the nuances of GFCI protection, proper fixture selection, and adherence to the NEC are crucial steps in achieving this goal.